You've got your factory running, belts moving, machines humming, but suddenly your iron patch runs dry. The next one, 500 tiles away. Do you rebuild your whole belt system just to reach it? Or is there a smarter way? That's where trains come in, but trains are not just a replacement for belts, they're a whole new way of thinking. They're fast, but only if your signals don't trap them in endless loops. They're powerful, but only if your stations don't block your entire network, and they're scalable if you build it right from the start. In this video, we'll go beyond just placing rails. I'll show you how to avoid deadlocks, how to use chain signals the smart way, and how to build a network that grows with your factory. Because a poorly built train system isn't just inefficient, it's a ticking time bomb. Trains are the backbone of scalable logistics in Factorio. They allow you to move massive amounts of resources, fast, efficient, and that over long distances. At the core, a train is made up of locomotives, one or more, and cargo wagons. These wagons can carry either solid items or fluid, and of course, locomotives don't run on magic. You need to fuel them with coal, wood, or later on, nuclear fuel cells. But trains need more than just engines and wagons. They also need rails to move them around your world, stations where they can stop to load or unload items, signals to avoid collisions and keep things flowing, and finally schedules, which tells each train where to go and when. A key aspect of train automation. As your base expands, you'll notice that ore patches are getting further and further away. At some point, belts just aren't enough. That's where trains come in. They bridge those distances and they do it much faster than even the fastest belts. Unlike belts or pipes, trains are scalable. You don't need to run new belts across the entire map each time you discover a new ore patch. With trains, you just build a new station and hook it up to your existing rail network. It's also much cleaner. Instead of turning your base into a spaghetti mess of belts and underground pipes, trains let you build centralized, modular factories. Need stone at the top of the map and iron at the bottom. Just build a station near where you need each resource, connect it to your network, and it's done. But before your trains can move, they need something to move on, and that means building a solid, reliable rail network. Track layout is one of the most important early decisions you'll make when setting up your train system. It might feel tempting to start simple with just a single line of rail, one track where trains go back and forth, and for every first train that might actually work fine. But as soon as you add a second train to the network, problems begin to appear. Trains will face each other head-on, waiting endlessly for the other to pass, causing traffic jams and even complete deadlocks. When that happens, neither train can move forward, and they'll sit there waiting indefinitely for the other to back up, which, without manual intervention, they won't do. This quickly brings your entire rail network to a standstill. What starts as a minor delay turns into a full-blown traffic jam, and if more trains join the line, it can lead to a chain reaction of stalled locomotives. That's why one of the first golden rules of train networks is this: avoid single tracks. Instead, build a double track system, one rail for each direction. This setup instantly solves the traffic issue and allows multiple trains to move independently and smoothly, even when they're headed to the same destination. It's a small investment upfront that will save you hours of frustration later. Of course, this also means you'll need a lot more rails, and rails aren't cheap in large quantities. Each segment costs stone, iron sticks, and steel, and if you try to handcraft them every time you expand, you quickly run out of patience. That's why it's a good idea to automate the rail production early. Not only will this support your growing train network, but rails are also used to make science pack later in the game, so having a constant supply is a win-win. As you're laying down tracks, there's another tip that can save time and add utility. Use the opportunity to also place big electric poles along your rail lines. Since your trains will be moving between outposts and your main base, they often need electricity. Whether it's for mining drills, roboports, or defenses, and if you throw in radars along the way, you'll also gain visibility over the areas your trains are passing through, revealing biters, resources, or expansion opportunities. So, as you start laying down your first rails, think ahead. Trains are fast, powerful, and scalable, but only if the tracks beneath them are designed with growth in mind. Now that your tracks are in place, it's time to talk about signals, one of the most important and most misunderstood parts of building a train network in Factorio. Signals are what prevent your trains from crashing into each other. They control traffic, keep trains moving smoothly, and help avoid deadlocks. and while the concept is simple, using them properly makes all the difference between a smooth rail system and one that's constantly stuck. So let's break it down. First, we have the standard rail signal. Its job is to divide your track into blocks. Each block is simply a section of rail between two signals. When a train enters a block, it claims it, and the signal before that block will turn red, telling any following trains to stop. As soon as the block is free, meaning no train is currently in it, the signal will turn green, allowing the next train to enter. This system alone already makes your rail line safer, but it's not quite enough for complex intersection, and that's where chain signals come in. A chain signal looks not just at the next block, but into the next signal after that, and even the one after that if it's also a chain signal. It chains forward through the network until it reaches a regular rail signal. Why is this useful? Because it allows train to look ahead and make better decisions before entering intersections. Here is how a chain signal behaves. Green means all the paths ahead are free and the train can go through. Red means every option ahead is blocked, so the train must wait. Blue is a bit more nuanced. It means that some directions are blocked, but the train is smart enough to know which direction it's heading. If the way it wants to go is clear, it will proceed. If not, it will wait. This is especially helpful at junctions. You don't want a train entering an intersection and blocking it while waiting for its turn. That's how backups and gridlocks start. So the general rule is use a chain signal before the intersection and a regular rail signal just after it. That way, trains only enter when they know they'll be able to exit, keeping the intersection itself free and fluid. Now, an important tip for beginners: simplicity is key. Stick to a double track system, one track per direction, and place signals on both sides, one for each lane. Don't get carried away by placing a dozen chain signals in a row thinking it'll be smarter. Overcomplicating your signals often causes more problems than it solves, especially early on. Another smart move is to place signals along long straight sections of track, not just at junctions. This allows multiple trains to follow one another closely on the same path, instead of waiting for the lead train to travel the entire length. This makes your whole system feel faster and more responsive. But be careful, signals only help if you leave enough space between them. Trains need room to stop. If a train is too long and can't fully fit in the space between two signals, it'll end up overlapping into the next block. When that happens, both blocks become unusable. What should have been space for two trains is now blocked by just one. That leads to congestion, reduced throughput, and potential deadlocks, the very things signals are meant to prevent. So remember, use rail signals to divide tracks into safe blocks, use chain signals at intersections to keep them clear, keep it simple with one track per direction, add signals to long stretches to improve flow, and always leave enough room for trains to stop fully within a block. Mastering signals might seem tricky at first, but once you understand how they work, they become one of the most powerful tools for building a scalable and reliable train network. Now let's talk about intersections, one of the trickiest parts of train network design, but also one of the most important. When two or more train lines cross paths, things can quickly get messy, so here's a rule to live by. Keep intersections as simple as possible. The more complicated your junctions, the harder they are to signal correctly, and the more likely they are to cause traffic jams or deadlocks. There are lots of ways to design intersections, but one of the most reliable and beginner-friendly options is the roundabout. It works well for 3 or 4 ways connection, and because of its circular flow, trains can navigate it efficiently. That said, a 3-way roundabout is usually preferred, since it reduces the chances of congestion. Here is how to signal a roundabout properly. Place a chain signal at each entrance to the roundabout, then place a regular signal at each exit. The chain signal ensures that a train will only enter the roundabout if its exit path is clear. This prevents trains from getting stuck inside and blocking the entire circle. Meanwhile, the regular signal checks whether the block after the roundabout is free, allowing trains to exit safely. Let's look at a few scenarios to understand better. If all exits are free, the train gets a green signal and goes through without stopping. If all exits are blocked, the train gets a red signal and waits. If some exits are blocked, but the one the train needs is clear, the signal turns blue and the train moves forward. If the desired exit is blocked, even if others are clear, the signal stays blue, but the train waits. It's smart enough to only proceed if its specific path is open. This system keeps the roundabout flowing without letting trains clog it up. It's simple, effective, and easy to expand later. So remember, when it comes to intersections, simplicity is your best friend. Use roundabouts with proper signaling, and you'll avoid a ton of headaches as your train networks grows. Once your tracks are laid and your intersections are working properly, the next step is setting up stations, the places where your train stops to either load up or drop off resources. There are two main types of stations in any train network: loading stations and unloading stations. A loading station is usually found at an outpost, somewhere you're mining iron, copper, coal, or other raw materials. This is where the train gets filled up with resources. On the other side of the network, closer to your base, you'll set up an unloading station where those same materials get dropped off to be used in your production lines. Whether you're moving solids or liquids, the principles are the same, but the setup is slightly different. For liquids, it's very straightforward. You simply need a pump connected to the fluid wagon. The pump will handle the transfer, either filling the wagon at a loading station or emptying it at an unloading station. As long as the pipe network is connected properly and powered, the transfer happens automatically. For solid items otherwise, you need a little bit more structure. First, set up buffer chests near the train stop. These hold the resources waiting to be loaded into the train or store the ones that have just been unloaded. Then use inserters to move the items. Inserters pull items out of the wagons and place them into chests, or the other way around. You can also use fast or stacked inserters for better throughput, especially later in the game. One important but often overlooked detail is signaling near stations. A badly placed station can block your entire rail line. To avoid that, add a normal signal at the start of the station siding where the train leaves the main track, and a change signal at the end, before it rejoins the main track. This ensures the train only enters the station if it knows it can exit cleanly without sitting on the main rail and blocking other trains. Additional regular signals can be added if the space allows it. This allows multiple trains to wait for their turn at the stop. So to recap, loading stations are usually at outposts and fill the train. Unloading stations are at your base emptying and fueling the train. Liquids needs pump and fluid wagons. Solids need buffer chests, inserters, and proper signaling. With a good station setup, your trains will stay fast, efficient, and most importantly, reliable. Now that your stations are in place, it's time to give your train some direction. That's where scheduling comes in. You can always move your trains manually, but this is Factorio. Automation is the name of the game. To make your train network efficient and hands-free, you need to use the Schedule tab. A train schedule is simply a list of stations it should visit. You assign these stations in order, and the train will follow that route, but, and this is important, trains won't automatically stop at each station forever. You need to tell them how long to stay or what condition must be met before they move on. The two most common conditions are wait until the cargo is full, typically used at loading stations, and wait until the cargo is empty, usually set at unloading stations. You can also set conditions like waiting for a certain amount of time, making sure the train is fully fueled, or even using circuit network signals for advanced setups. This gives you a lot of flexibility, even with basic train automation. When naming your stations, keep them simple and descriptive. For example, iron loading or copper unloading. This makes it much easier to assign the correct station when you're scheduling multiple trains later in the game. Also, don't forget one practical detail: your unloading stations need space. The resources you bring in often go straight into smelting arrays, and furnaces take up a huge amount of room. If you don't plan ahead, you'll find yourself out of space very quickly, so always make sure your stations, especially unloading stations, are placed where there's room for expansion. To summarize, use schedules to automate where your trains go and when, add conditions to control when trains leave each station, name your stations clearly, and leave space for your production to grow around the unloading areas. With proper scheduling, your train network becomes fully automated and incredibly efficient. No more chasing after locomotives or worrying about supply delays. That wraps the fundamentals of train networks, and once you've mastered the core mechanics, there's a whole new level to explore, things like stackers to manage traffic, smart trains with circuit logic, and fully optimized network for megabases. If you found this helpful, hit like, subscribe, and leave a comment about what you'd like to learn next. See you soon for another video.